Well, hey there, Troll Pal, Mr. Cook. We're gonna go through the test review. I guess 4 problems at a time or something. So we'll do these ones first. These are the area bounded by the curves. First step is to graph it. Sometimes it's a little challenging, like if your input is y, but if you just I'll show you a shortcut for that one. It's not that bad. And then after you graph it, find intersection points. Points, PTS. There we go. Or corner points. And then after that, you find your area by setting up an integral. So it's going to be the top function minus the bottom function. All right. And then, decide if you're going to use dx or dy. Most of the time when you want to find the intersection points or the corner points, sometimes it'll be pretty obvious. Sometimes you need to solve for them. But you can always, if you graph it on your calculator, you can use your graphing calculator's solving function or intersection function to just get the intersection points. So I'm looking at these ones here. I probably wouldn't be able to find the intersection points by hand, so I just use my calculator. And if you want to know how to do that, just ask somebody, like your teacher or something like that. When we have to do this part, because I don't have my calculator with me. Actually, yeah, I do. I have my calculator with me. I'll defer to my calculator to find those. Anyways, okay, so let's start solving some of these things. So let's follow this process, graph them out, and then find the intersection points, and then set up the integral. Here we go. So number one, we have the function x to the third. So it's like this, x to the third cubic. And then we have some parabola. Oh gosh, I forgot what it was already. X squared minus 4x plus 4. So how does that one work? So x squared minus 4x plus 4. So that's like the factors. That's x minus 2 squared. So it'll go through 2. It'll bounce off of 2 here and go up. So it's like this. And then we have one more line, and that's, what's the last one? X equals 2. Okay, so x equals 2 is, well, that's that point right there. So it'll just pass through there. Oops, use a different color. There we go. So all three of these graphs intersect to form this region here. So that's going to be the area that we're going to look for. And so it's helpful to know all the intersection points, know where they're located. Like this coordinate's at 2, 0. That one's going to be at 2, 8 because it's, it has to pass through this equation. And then this one I'm not too sure about. What I would do is I'd take the two equations and set them equal to each other and solve for x. So x to the third equals x squared minus 4x plus 4. Then I'd solve it. So maybe I'd move all that stuff to the side. So I'd have x to the third minus x squared plus 4x minus 4 equals 0. And it looks like 1 is probably one of the coordinates. You can always use your calculator to verify it. But I always there's this trick that you can do to see if 1 is a factor of a polynomial, and that's just adding up the coefficients. If they add up to 0, then 1 is a factor of or a 0 of the polynomial. So let me do that. So the coefficient on the x to the third is 1. The coefficient on the x squared is a negative 1. The coefficient on the 4x is a 4. And then you have a constant of negative 4. If you add all those together, you get 0. So this means that x equals 1 is another solution to this. And that's probably where that coordinate's going to be right there. So that would be let's see, 1, 1, I guess, right? 1, 1. That last coordinate. Okay, let's set up the integral now. So the integral goes something like this. Let's see here. So I guess we can just, it's going to be the top function. So that's x to the third. It's the one on top, right, of this whole thing. It's above the most y, the greatest y values. And then the lower y values are going to be from this function here. And that's going to be that x squared minus 4x plus 4. And then we're going to take these two and subtract them from one another. So I have to put parentheses around this like this. And then it's going to be dx. So I'm going to subtract those two. And then what are the bounds on my limit? Well, on my integral, excuse me. It's just going to be from the beginning x value, which would be 1, to the ending x value, which would be at 2 right there. So from 1 to 2. And, you can just leave it like that. You do not need to evaluate it. You can just leave it as an integral, and you're done. Okay, let's take a look at number 2. All right, 2, graphing it out. Okay, now this is probably something that you're not really happy with. You have to use your y values instead of your x values as, like as inputs. But there's actually like a really simple solution to this when you think about it. Like, we pick x and y kind of arbitrarily to graph, right? Like if I do a graphing axis, I always put x here and y here, right? Well, I mean, you could just as easily just like change these, y here, x here, right? It's just like establishing a coordinate grid. So if you just change the position of the coordinates, it doesn't ultimately change the shape. It just rotates it. That's it. So that's what I'm going to do. I'm just going to change the two axes, and then things get really easy for me. So watch this. Now if I got to graph this thing out, so x minus 2y plus 7 equals 0. Right? Wasn't that it? Plus 7? Yeah, okay. So what I can do is just solve for x. So x is equal to 2y minus 7. So that like gives me this, equation down here. Let me extend the axis down there, the x-axis down. So it starts at -7. I would just graph this like I would, this equation, y equals 2x minus 7. And in fact, I could just type this in my calculator and graph it out. It's going to be the same graph that I'm going to get here, which is just like this line that goes like that. Okay. And you can graph it like this if you want. Nobody says that you got to keep the y-axis where the y-axis is, or the x-axis where the x-axis is. It's just sort of like labeling them, Anyways, all right. So that gives me, my first equation to graph out. A little circle, just put a little box around that. That's my red one. And then my other equation is this parabola right here. So y squared minus 6y minus x, or the plus x, minus x equals 0. If I move this x to the other side, I get x equals y squared minus 6y. So this is like a upwards facing parabola, and it passes through 0, 0, and then also 6, 0. So it's like this kind of. Yeah. And then like it connects somewhere over here. Maybe I'll extend that little red line up there. There we go. So it looks like we have two intersection points, one right here and one right here. And I better find out where those intersection points are. So what I'm going to do is take my two equations and I'm going to set them equal to each other to solve for the corresponding y values. So along the y-axis, where they intersect. So let's find those. Set them equal. So we've got 2y minus 7 equals y squared minus 6y. And then, solve it. So I'd like move all this stuff over to the other side. So I get 0 equals y squared minus 8y plus 7. Factor. So you get, y minus 7, y minus 1. Yeah. And that means that my two y values are 7 and 1. Okay. So like the y equals 1 is here, the y equals 7 is right here. And we can put together our integral now as well. So we're, since y is now like our x-axis or whatever you want to call it, like, we're just going to set up our integral using dy. So leave all the graphs, all the equations just in terms of y. It makes it easier that way. So the y values we're evaluating, the lower bound is 1, the upper bound is 7. So from 1 to 7. And then we take the upper function, which was that 2y minus 7, and we're going to subtract away the lower function, which was that parabola that we had. Not 6. It was just regular old y squared minus 6y, and then dy. And let me put a little bracket around there just to say that, hey, this whole thing is getting the integral. There we go. And you can, again, just leave it like that. It's the top function, that line, minus the bottom function, this parabola. And there you go. That's as far as you need to go with this problem, and you are all done. All right, let's keep going. So that's the second area problem. Now the third area problem. Oh yeah, this is definitely one that I'd need my calculator to solve, but and maybe even graph too. Actually, no, I know how these graphs look. Yeah, cosine. Yeah, this wouldn't be too bad. Right, yeah, because that just goes. This goes through the origin, and then goes up, And then this one is like a bell curve kind of shape. So it looks something like this, I bet. And you can you can use your calculator to tell if this is accurate or not. But that bell curve shape, it's like kind of like goes like this, up and then down like that. So that's like y equals e to the negative x squared. And then the other one, cosine minus 1. So that would go through 0, 0, and it'd be negative. So it'd go like something like this, like up and then down and then up again. But I'm thinking that they just want us to find the area between the curves here, here, and here. So that's what we would want to find. Okay, so let's you would now use your calculator just to find those intersection points. But basically, like what you're doing in reality is taking the two functions and setting them equal and then solving them. This isn't something at all that you'd ever want to do by hand. Never, never, never in a million years. So just use your calculator's intersection function instead, to solve it. So let me get my calculator out. Excuse me for a moment. All right, there we go. And if you could hear me, I was shuffling around my backpack. So this, I guess, kind of turned into an ASMR video to an extent, I guess. Okay. So now I'd use my calculator, see what the functions look like. So I'd press y equals, and then graph these out. E to the power of negative x squared, and 1 minus the cosine of x. And of course, you'd want to put that in radian mode. Just make sure it's in radian mode. And then hit the graph button. And you see that the functions look something like that. Okay, now to access the interception or intercepts function on your calculator, you hit second and then trace. Let me write it up real quick. Second, and then you go to trace, which is at the top of your screen of your calculator. And then you pick on mine it's the fifth option. It's called intersect, my bad. Or the intersect. And then it says oh, where is it intersect on the first curve? So you use the left and the right cursors, you get as close to one of the intersection points. I'm going to look for this one first. So I'm going to use the cursor to get as close to that point as I can, and then hit enter. And it says, what about the second curve? So now you're on the other function. And so you just use the left or the right cursor to get to that same exact point. It's usually like already on it, so you can just hit enter a couple times. And it says to guess, so hit enter again. And then they'll give you the actual point where it intersects. So for me, on my calculator, it looked like negative 0.941944. I'm just going to round it to 4 decimal places. And I'm willing to bet you anything that this is symmetric, so I bet that that's 0.94119. Yeah, I bet you anything. Well, I'm gonna try it again. So I'm gonna hit second and then trace, intersect, and then I'm gonna use the cursor and go over to that right intersection point. And I bet that that's where it is. Yeah, according to this, it is 9.9419 again. Okay, so now I know the upper bound and the lower bound on my integral. So I'm going to write it up. So let's see. It starts at negative 0.9419, and it ends at 0.9419. And then I do the upper curve, which is going to be that e to the power of negative x squared. And then I subtract away the lower curve, which is that 1 minus cosine of x, and I put that in parentheses because I'm subtracting the whole thing. And then I'll put the, the brackets around the whole thing, and then do my little dx. There we go. So there's my integral, the area between the curves, and the area represented in this little shaded region here. Of course, if I wanted to, I could, find more curves that are bounded there. I'd like, if I were to rewrite this a little bit, I'd probably like, say that it's, also, just the first intersection points or something like that, or the ones closest to the axis. I don't know, something like that. Because technically, like, this is a shaded region too, and we'd have to find that. Same thing here, and so on. It's probably like infinitely many intersection regions. But anyways, okay, so I digress. So let's go ahead and go to number 4. So number 4, we've got a exponential function, then y equals 8 and x equals 0. Oh, that's not too bad to draw out. So the 2x, 2 to the x, looks something like this. You graph it out on your calculator. And then the line y equals 8, that's just like a horizontal line, y equals 8. And then the last line was that x equals 0. So the shaded region goes like right here. And this one shouldn't be that hard to graph. Like, it's just you do the top function, and the top function is weird. It's this, number 8. Just 8. It's the height. That's the top function. And then we're going to subtract away that that exponential function from it. So here's how our integral is going to look. Oh, wait, never mind. I'd better also figure out that intersection point. I haven't even done the intersection points, darn it. So let's see. This one's going to be at 0, 8. This one's going to be at 0, 1. Oops, 0, 1. Darn it. And then the last one, let's see. So let's set those equal to each other. 2 to the x is equal to 8. That's 2 to the third equals 8. So x is equal to 3. So that'd be 3, 8. There we go. All right, so my integral, it starts at 0 along the x-axis, and then it goes all the way to 3. So from 0 to 3, that's where my integral is going to go. And then it's the top function, which is 8, minus the bottom function, which is 2 to the power of x. And put a little bracket around it, or parentheses, and then do dx. And this one's done also. I can just kind of leave it like that. We're through. There you go. That's the first 4 problems. I think that's enough for this video. And then we'll move on to the next one, which is going to be like the disk method and stuff like that. Okay, I'll see you in the next video. Bye-bye.